Hello to all engineers. My name is Victor Da Silva, and today I'll be talking to you guys about the statistical tool called linear regression. Before anything else, I'll be explaining what exactly is linear regression modeling. Linear regression is a tool that allows us to mathematically model and predict the relationship of two or more variables, one of them being a dependent variable and the others being independent variables. In simple linear regression, the prediction of y when plotting as a function of x form a straight line. Linear regression consists of finding the best fitting straight line to the plotted point. The best fitting line is called the regression line and is found by minimizing the sum of the squared errors of prediction. The error of prediction is the distance from the plotted point to the best fit line. Linear regression is very useful in engineering because it can make challenging problems have simple solutions due to the very simple algebra that's used. Some examples of how linear regression can contribute to simplifying civil engineering problems are to predict and classify construction cycle times, finding the coefficient of thermal expansion given the temperature of steel, and identifying flexural behavior of beams under repeated compressive load and predicting the actual location of faults and underground optical networks using linear regression written by Owusu Nayarko-Boateng discusses how optical cable has been an indispensable component of data communication infrastructure. Therefore, the engineering plan is to optimize the difficult task of detection of faults underground, as it causes an undue delay and loss of revenue. According to Boateng, engineers used a machine learning approach to predict the actual location of fiber cable fault in an underground optical transmission link. When the linear regression model is applied, the training data was defined as xi, which was the input value obtained from the OTDR, which is the device used to trace faults in optical cables measurement, and yi is the predicted location. The linear regression model applied in the project gave accurate results, and the engineers were able to overcome the challenging task of predicting the location of faults underground. Finally, I will present to you some strengths and weaknesses about linear regression models. The strengths are that linear regression is very straightforward and clear, and it can be easily regularized to avoid overfitting. The weaknesses that this model presents are that it performs poorly when there are nonlinear relationships, and also they're not naturally flexible enough to catch more complex patterns. That wraps up the video on linear regression. Hope you guys enjoyed. Bye.